Hello and welcome back to another VMK in the game development series. In this VMK we're going to go and reintroduce our textures into our game engine. We had them working before, but whenever we modified our code to work with the scene graph, we took out the texture stuff just so that things would be a little bit cleaner and easier to understand. Now that we've built up the scene graph and we've already added materials to it, let's go ahead and now add textures as well. We're going to begin by taking a look at the texture class that we developed previously. Let's open up here. We have our regular constructor, a destructor, a load, and a create texture OpenGL. We're not going to change any of these functions. As a matter of fact, we're going to keep everything pretty much the same. First thing I would like to do is modify some of the code that we have in these functions, but leave the function structures the same as it is right now. Now what I mean by this is I'm not going to be adding any different kinds of parameters to be passed into the constructor, the load, the create texture OpenGL. We're going to leave that the same, but we are going to go inside these functions and make a couple adjustments. First adjustment we're going to make is inside the create texture OpenGL function. What we do here is we call this function after we've already loaded a texture into memory. And you'll remember that when we do load things into memory, it gets stored inside this member variable here. This member variable contains all of the pixel data that was stored inside of the file. After we have that information, we then go and call create texture OpenGL through a function within our scene, and what it's going to do is define an ID number for this texture, and then we enable the textures, we bind the texture to that ID, and we set the filters and the way we're going to wrap the textures, and then we call this GL texture image 2D with all these different parameters. I was doing some background reading on OpenGL and I discovered that this third parameter here for GL texture image 2D, we're currently using either GL underscore RGB or GL underscore RGBA, depending on whether we have an alpha channel or not. Well, in my background reading, I discovered that if you add an 8 here to the end of this parameter, this new parameter, GL underscore RGB8, is actually a way to force your video card to optimize the way that the textures are stored in memory. If your video card doesn't support this setting, then it's going to default back to RGB, GL underscore RGB, and it's not going to worry about this 8. But the 8 does help. So I'll ask you to also add this 8 here as well as this 8 here, just so that if your video card does support these, then you can go ahead and take advantage of these settings. The other thing that we didn't do before is you'll notice that we take all the data that's stored inside this member variable and we call this function. Now what this function does inside OpenGL is it takes all of the pixel data stored inside this member and saves it either on the video memory or in some other reserved memory that OpenGL only has access to. So after we do this GL texture image 2D function call, there's no need for us to store this data ourselves, because OpenGL is now handling it for us. So right down here we're going to add one extra line of code, and that's what we see here. Safe delete array, and then we pass in the parameter. So in other words, what we're doing is we're deleting the data that's stored inside this member variable. We don't need it because now OpenGL is handling the pixel data for us. This is something that you may or may not run into a problem with, depending on how much video memory you have on your video card. If you're loading a lot of textures, you could be bogging down your system because you're storing 2 copies of all the textures, one in video memory and one in regular memory for your CPU to use. Since we're never going to use this ourselves, we only rely on OpenGL to use it, we can go and delete it after we set all the image data inside OpenGL. So that's what this does. It frees up the memory used to store the pixels in memory. OpenGL is now storing the pixels for us, and that's what the comment there says. The other thing we can do is inside of our destructor, we go and call this delete for the image data, we don't really need this if statement. I keep forgetting that inside the safe delete function call, we have an if check. You can see there in the tooltip, if p, then would delete it and then set the value to null. So we don't need that if check. The one thing that we can do up here though is delete the ID number that this texture was using. So whenever we call this the destructor for this specific texture, we check to see if it has an ID number. And you'll remember inside the constructor we set the ID number to 0, but whenever we go and call create texture OpenGL, where is it? Down here, we specify an ID number, and this ID number will always be greater than 0. So back inside the destructor, if the ID number is greater than 0, then we know we have a texture already stored. So what we can do is call GL delete textures, and this function call is actually going to delete the pixel data that was stored by OpenGL. So it deletes whatever this function call here stores for us. Now, if for whatever reason we created a texture but we never called create texture OpenGL, then we still have our own pixel data. So we still need this safe delete down here to delete the pixel data from our own memory. So that's how we ended up having both of these deletes. One delete for the OpenGL and one delete for our own data if we still have it. Okay, so those are the changes I wanted to make inside the texture class. Now let's go and implement a method for us to bind a texture to an existing object inside of our scene. To do that, let's go into, where's our scene, and back into initialize. You'll remember when we're handling materials, what we did is we created a bunch of new materials at the top here, and then whenever we wanted to use those materials, we created a function called assign material. And this function takes a node ID, which should be a shape, and another material ID parameter into it. And then using these two parameters, it then attaches this specific material with this specific node. Well, we're going to do the same thing, but now with textures as well. A lot of this code is going to look very similar to what we did here with the materials. First thing we'll do is go inside the scene.h file, and we need to create this function prototype. So where's the texture stuff? Up here. We have load texture, delete all textures, and then we had select texture and select texture ID. We're no longer going to need these, so we're going to delete them and replace them with this function here called assign textures. And we're going to pass into it a shape ID, which is going to be a node, and a texture ID, which is going to be the ID number to the specific texture we want to attach to this specific shape. So let's go and delete these two functions. And we might as well go inside of our code and delete the stuff that refers to selecting the textures. Here's the select texture ID and select texture. Okay, so they're gone now. And underneath load texture, we have delete all textures, and then right here I'm going to put that new function assign texture. It's pretty short. So again, we pass in a ID number for our node and an ID number for our texture. And what we're going to do is we're going to check to see whether this texture ID is valid. And it's valid if this texture ID number is less than or equal to the size of the container that's storing all of our textures. If it's greater than that size, then it's invalid because there's no room for it. So we just generate an error message and we return false. We then check to see if the shape ID that was passed into us is valid. And again, we do a comparison with the size of the container that holds all the nodes. And if this fails, we return an error message. Otherwise, we continue on through. Then what we do is we check to see whether this specific shape is actually we check to see if this specific is actually a shape node. So we extract the data that's contained inside the container for that specific shape. Now remember, this container is a 0 index, so that's why we have to subtract 1, and we call isShape. If this returns true, then this not operator is going to skip this if statement and we continue on through. However, if isShape is false, then we're going to go inside this if statement and generate this error message saying that this specific ID number, UI shape ID, does not belong to a shape. So then we generate an error message and we just return false. If we've gotten down to here, we know we have a valid shape ID and a valid texture ID. So then all we need to do is take the specific shape node, and we can take the texture parameter within it and set it equal to the texture that we're passing in here. So again, it's 0 index, so we take the value -1, extract that value from our container that's holding all of our textures, and assign that to the pointer that's going to point to the texture here. Now, we need to go inside of our shape node and add this parameter here because we've commented out previously. Going in here, node shape, inside the .h file, we'll have to include texture.h, and down here we're now going to include the texture pointer. And the other thing we need to do is go inside of the constructor. Where is it? Node shape constructor. We initialize it to null, and then down here, whenever we go and render, we need to go and do some extra work because we'll now have a valid texture ID, a valid texture pointer if we've assigned a texture to this specific object. But before I go and write this code, I just want to compile this to make sure that I haven't missed anything. Okay, everything still looks fine. Now let's go into our scene, initialize, and see how we're going to load a texture in. As a matter of fact, it's not going to be any different than here when we're working with the materials. Let's see, we're making geometries, then we have making materials, and let's say right after that we're going to have loading textures. Okay, we create an unsigned integer and we're going to call it UI text ID, and we then create a pointer to a texture, and we set the pointer equal to new texture, and we pass in our error handler. If this returns false, then we generate an error message. Otherwise, we then call load texture, and we pass in the texture pointer that we want to load this texture into, and the path that we want to load the texture from. So inside the resources textures folder, I created a file called create.tga, and you'll be able to find this same file here inside the VMK under texture directory. So just take that and put it also inside your resources textures folder wherever your project is handling all the resources. So this will load the texture, and then after we've loaded it, we need to now go and specify a box that we want to assign a texture to. Let's see. Which box is this? Box 2. Well, actually, to make things easier, let's not assign any materials to our objects, because I think we still have our red and green boxes from before. So let's just comment all that stuff out, and here we're going to call assign texture. Now it's asking for a shape ID, so we pass in UI node ID and then UI text ID. So this first box, which I think is the one that's straight in front of our faces, will have a texture on it. The other two will not. And I think all of them should still be gray because that's the default. But for this to work, we need to go inside of our texture class and make some modifications here. or sorry, not our texture class, our node shape class. So here, if we have a texture, we have to handle our class slightly differently. And this is what we do. We first need to enable textures since we're going to be using a texture. We bind the specific texture that this texture pointer points to. So we pass in that ID number and we set GL texture 2D. Then we go and render, and then after we finish rendering, we disable the textures because we don't want any other objects inside the scene to also use this texture. So we're only enabling it, rendering that one object, and then disabling it at the end. Okie dokie. So let's go and build this and see what happens. Okay. What we have there is a rotating textured box in the middle and then two gray boxes on the sides. Just what I was expecting. But I did forget that we are rotating them, so it's a little bit hard to see things. Let's go in here and disable those rotations. As a matter of fact, I might as well just comment all this out. Okay. So as you see there's our box in the middle of the screen, and it's been textured. And if I actually go into PaintShop Pro here, you can see the texture that I created. Oh, wrong file. This one here. All it is just a wooden kind of texture, so it kind of looks like a crate is mapped on top of that box. And the size of this is 128 by 128. So that's pretty easy, right? Well, what if you didn't want the box to have the same texture on every side? Because you'll notice that when I run it now, on every side of this box, it's the exact same texture. On the sides, on the front, on the top. It's all the same thing. So it's not great. What we can do, though, is change it so that the texture is different depending on which side of the box you're looking at. And to do that, what I'm going to do is create a texture, a different kind of texture. And this texture that I've created here is a 2x2 texture, or I call it crate 2x2. And what I've done is I've subdivided the texture into 4 sections. There's the top left, top right, bottom left, and bottom right. And you notice each side is slightly different. Now, a box has 6 sides, but this image here has only 4 sides defined for the texture. So what I'm going to do is I'm going to specify, the top left-hand corner, this one here, which I'm circling right now, that's going to represent the top and the bottom of the crate. So that's the part of the texture image that is going to be rendered on the top and bottom. This one here, I'm going to say is going to be rendered on the front side. This one down here will be rendered on the back side, and then this one down here is going to be rendered on the left side. So in other words, I need to figure out the texture coordinates so that I can point my specific faces to this portion of the texture or this portion or whatever. And then in the end, when it goes and renders, OpenGL will know how to extract the specific data from this one texture image into multiple faces of our one object. Very similar to how we handled our house whenever we started working with textures inside OpenGL. So this is the texture, and again, I'm just going to write this out for you so you have a visual representation of what I'm going to be trying to do here. So I have my box here. This is just a rough drawing. And remember, I've divided it up sort of like this. Those should be straight lines. It's just that I can't draw straight lines with my hand. Okay, this bottom corner of the texture is 0, 0. This top right-hand corner of the texture is 1, 1, according to texture coordinates. This one here is going to be 1, 0, and this one here is going to be 0, 1. Remember, the first coordinate is the x value, so the horizontal distance, and the second coordinate is the y value, so the vertical distance. Now, we also need to know the coordinates of all these inner points as well, because they're going to define the edges of each of these sections. So this one here is 0.50. This one here is going to be 0.5. This one here is 0.5, comma 0.5. This one here is 1 and 0.5. And this last one here is going to be 0.5 and 1. Okay, so those are all the coordinates. And remember, I said that this top portion I'm going to use for the top as well as for the bottom. This one here I'm going to use for the front. This one I'm going to use for the back. And this last one I'm going to use for the left and for the right faces. So these images here are going to be used twice, this one here and this one here, whereas the front and the back are only going to be used once on the box. Now you can define how you want to map your textures on your own boxes, it doesn't matter. I just want you to see this representation of what I'm doing so that you understand how to use this yourself. And the reason why I've chosen left and right to have the same image and top and bottom to have the same image, because if you imagine any kind of boxy geometry, usually the top and the bottom you can get away with having the same image, and same thing with the left and the right, and have the object still look correct. So for instance, let's say our box itself was to represent a briefcase. Well, the left and the right side of my briefcase could be, for instance, a very simple black image. So I would put a black image here. Then the top and the bottom of the briefcase, well, the top should have some sort of handle on it and the bottom should have like feet. Well, the top and bottom would then have to go inside the front and the back sections. And then the top and bottom section here could represent the left and right side of the briefcase. I don't know if that makes much sense to you, but just think about a regular briefcase. You have the front and the back, which should basically look the same. The top and the bottom would look different, but the left and the right side would look the same. So again, you could just map out how you wanted to represent your briefcase in this sort of format. Anyway, going back to our code now, let's take a look on how to modify our geometry for the box so that we can use this 4x4 representation. We need to go into our object library inside the geometry box, and we want to go inside the render OpenGL section. Okay, in here we've divided the sections according to faces. So we have the front, the right, the back, the left, the top, and so on. And each of these sections currently have texture coordinates that specify the entire texture from 0, 0, 1, 0, 1, 1, and then 0, 1. Well, we no longer want to use these coordinates. We want to use our new coordinates that will allow us to use the 4x4 texture instead. So for the front face, going back into this diagram here, we see we should be using these coordinates, 1, 0, 5, 1, 0, 5, 1, 1, 0, 5, 1, and 0.5, 0.5. So those are the coordinates we need to go and change inside of our code. So let's go ahead. I'll do this very quickly and then just scroll through to show you what they should be. Okay. So you see now the front face uses 0.5, 0.5, 1, 0.5, 1, 1, and 0.5, 1. So those are the new texture coordinates for the front face. Then we have the right one, which are seen here. We have the back side, seen here. The left side, the top side, and finally the bottom. So going back, if you want to see where I got these numbers from, just refer back to this diagram here. Take a look at the values for the texture coordinates and refer back to this code here to see which of these coordinates are corresponding to which texture coordinates. Okay, now let's go and into our scene initialize. And where's our texture? Down here. We can now call, instead of create TGA, we want to call create 2x2.tga. Like so. Let's build this and take a look. And there we go. We see there's the front side has that cage kind of look. The left side and the right side are the same. The back side is also the same. And the top side has the fragile sign. Now notice though that where would that be? The right side and the back side are actually mirror images, or they look kind of rotated. The boards are running horizontally on this side, whereas here they're running vertically. So it is a different texture even though it looks somewhat similar. And that cross beam kind of goes up and down, kind of like in a Z pattern. And that's because we're using different textures for different sides of, now, see, here we have the one which is horizontal, here we have the other one which is vertical. So they're different, but they somewhat look the same. So there you go, that's how we handle textures inside of the scene graph. It's actually very easy. We can load textures, assign them using our new function called assign textures, and the textures automatically get linked in to our shape node. And remember, we can use multiple, we can use the same texture on multiple shapes. So for instance, let me put the same texture on every single box we have in the scene here. You remember, you should only assign textures to our node shapes. If you try to assign it to a transform node, then you will get an error message. Did I put this one in the right spot? No, this one's also in a texture transform. So make sure you put them in the right place. Oh, the other thing I should mention though is the textures and the materials will mix together. So if we have let's change the material colors here a little bit. Actually, why don't I just reassign the materials so we can see, because the materials already have different colors assigned to them. So we have material number 2, material number 1, and we have material, we'll change this to material number 3. Okay, so now you can see I have a red crate, a green crate, and a blue crate. And they're all kind of transparent because some of my parameters here were set to make these guys transparent. Let's just disable that so it's a little bit easier to see. Okay, so now we have 3 solid boxes with textures applied to them. And the material color pulls through the textures themselves. So you can tinge a texture with a specific color. This is kind of important because if you do go and render things and you notice that, you know, my texture itself wasn't green, but the object on my screen looks green. Well, it might be because you've assigned a green material to the object. Even though the texture itself has no green in it, it's still looking green because of the material color. So that's just something to remember and look out for. If you do want to assign a material to them, a good material to use is white. If you use white, then the color that the texture is the color that the object will appear when there's a white material attached to it. So here, I've just changed this material number 1 to be completely white, and you'll notice that now this one here is the true color of the texture. If I don't assign materials to the other guys, let me scroll down here. Where are they? Okay, here's this one. Let's take this material off. You'll notice this guy actually looks a little bit dim. And the reason why he's looking dim is because he's using the default texture, or the default material value, which is kind of gray. And the gray mixes in with the texture to make it look a little dimmer. And I don't know if you can tell or not, if I turn my flashlight off, you can sort of see that the box on the left here is a little bit dimmer than the box on the right, because the box on the right has a white texture applied to it, so it looks brighter than this one here, which has a gray texture attached to it, so it looks a little bit dimmer. Okay, so there you go. Those are textures. Come back for the next VMK, where I'll be adding different kinds of abilities into the texture class. And these abilities will actually help optimize the way the textures are handled inside your game. You'll notice now that all the textures are only rendered one way, and that's with the one texture we're assigning. Well, in the next VMK, we're going to apply mint mapping, which is a technique that sort of simplifies the texture depending on the distance that you are from the object that has the texture. And this will help improve performance as well as make your images look a lot better. So come back for that next time, and if you have something interesting that you're developing, send me an email, and I'm very interested to see what you guys are developing.